This training video will go over moving points from survey data using AutoCAD Civil 3D 2022. Topics being covered in this training video: GPS benchmarks in Civil 3D, moving points from general location to geospatial location, aligning the points to the photo that is preloaded in Civil 3D, and then exporting the points to the new location. You can download the GPS benchmarks from the filing location and add it to Civil 3D. Under the NRCS SharePoint site, Civil 3D support files, the Maryland NGS benchmark zip file. You can download that zip file onto your C drive and unzip the file. Open up your drawing in Civil 3D, type in the command line map import, navigate to the location where you unzip the file to, and make sure that the file type is set to .shp, which is a shape file, and then go ahead and click OK. An import window will appear. You want to then go ahead and select data. Another window will appear. Go ahead and click Create Object Data. Select Create Object Data, OK. And then after that, you want to go ahead and click OK again to complete the import. Now you should see a bunch of points that are located on the Maryland NGS benchmarks layer, which is shown in white on this photo. If you select any one of those points, you can view the properties and see the elevation, and there's also a link to the website that you can copy and place in your browser to see actual photos of the benchmarks and more information about that point. So if you select a point and have your properties dialog window open, it'll give you the point elevation, the location of where that point's at. So in this case, it's 38.874. And this is the data source link that you can copy and then place it in your browser. Once you place it in your browser, this is the actual data sheet that comes up from the browser website. And then if you want to, if there are photos, sometimes there's not, you can go ahead and select the hyperlink for the photos. And then once you select that hyperlink for the photos, if there are photos, you can go through and see what those photos are, so you can see an exact location of where that GPS point is located. So you can use these GPS benchmarks as a guide. So if you are close to any GPS point that you brought in from that in Civil 3D, you're able to move your points to that location, or maybe you shot it and then you know exactly where that shot is. You can change your elevations of your survey based off of that actual point elevation. In instances where you are moving points, which, is not a very good idea to begin with, but if you really had to, I'd recommend that you had this at least loaded in, and if you could shoot an actual benchmark that is loaded into this datum correctly and is given a specific elevation, then it's recommended that you go ahead and shoot that, and then that way you can adjust your points accordingly based off of that actual elevation and location. So the first step in order to get the GPS points into Civil 3D, must go on the Civil 3D support files website under SharePoint, and you'll notice the Maryland NGS benchmark zip file. You want to go ahead and download that into your C drive and then unzip that file or folder. Open up Civil 3D, and then what you want to do is just type in the command line map import, navigate to where you exported or unzipped that file, and make sure that the file type is set to the shape file. So you want to select that Maryland NGS benchmark shape file. Go ahead and click OK. The input layer is the Maryland NGS benchmark, so it'll create an actual layer called the Maryland NGS benchmark layer. It says the input coordinate system is the Maryland 83, not 83. The spatial filter, if you wanted to just have the points come in where you are, have done the survey, you can do the current display, but in this case we're just going to go ahead and import them all into the drawing. So under the data tab, if you select none, it won't bring any information of that point, like properties, into it. So you want to go ahead and select the three dots, and it brings up another window, the attribute data window, and you want to go ahead and select the create object data, and then the Maryland NGS benchmarks, and then go ahead and click OK, and then you'll see that the data has been added, and then go ahead and click OK. You don't have to worry about import polygons as closed polygons because these are actually points. So it processes this, importing all that data into your drawing, and once those points are added, you'll notice all these little white dots everywhere. And if you select any one of these, dots, and you go to your properties window, you'll notice over here that it gives the information of that specific, point. So if you do select a point for this example, and you go to properties, you'll notice the elevation. It gives you some other information about that point. But what I want to show you is if you select a data source, just highlight it and hit the Control-C button and go into your browser. And then you can just paste that in here. And then this gives you the information of that specific point. And then if you actually wanted to see photographs of it, you can go ahead and select photographs. And in this case, there's 3 different ones. So it gives you a good amount of information based off of what that actual survey point. So that's a useful tool moving forward with the GPS points and moving the points. If you can find a location of where you actually have a GPS point that you're doing your survey, it's highly recommended that you use your survey elevation based off of that, because that is a known point elevation. And then that way you can take your surveyed points and align them to this specific elevation and adjust your elevation of your survey points to this elevation that is known. If you don't have one close by, then the next best step to do is just keep your points the same elevation of what you surveyed them as. Leave those points alone as far as elevation. But if you did want to change those points, you could use the benchmark ones. That's the only time I would recommend if you wanted to change an actual survey point. Otherwise, you're just guessing as far as a point elevation. So most of us that do surveys and don't have access to GPS, most of the time you're used to using 5,000 northing and 10,000 easting. And you will not have a map behind that survey because a survey was not completed in a specific datum. This process will go over how you take those points and move them to a location that's geospatially referenced, close enough to where you're using that photo in the background. It's not used to do stakeouts and things like that based off of the photo in the background, because that photo is not completely accurate. When you do GPS surveys and bring in GPS points, if you notice sometimes those points might be off. If you have a corner of a building because of the overhang or the shadowing of the actual photo that was taken, it might be off 5 to 10 feet. So you don't ever want to use that photo as a point of reference to do any type of stakeout work. That should all be localized and surveyed line of sight data that you're doing that with. So this is just a reference to have that photo behind, your actual survey. The first step is to make sure that you create a copy of your original survey. So you'll notice here that, we started with 5,000, 10,000. That was our instrument point. And then we continued on with the survey. And what I recommend doing is that at the end of your survey, your original survey, just put, .org at the end of it, just so you know that's the original survey points. For any reason, if something happens and you have to go back to those original survey points, you at least have a copy of them. The next step is to locate a point that you can move from your survey points to a location shown on the map in Civil 3D. This can be a building corner, edge of road, or anything that you can see on the aerial map and have a survey point of. It's recommended that if you're going to adjust your survey points, make sure that you survey multiple building corners or any other structures that may show up on the aerial map. My recommendation is to look at the aerial map and see what structures or buildings that you should be taking shots of, so you can move those points to, if you're not in a datum. And then that way it'll be a lot easier. So if you go out to an open field that has nothing out there, it's going to be very difficult to move those points, to have that map adjusted behind it. You can use edge of woods and things like that, but it's just not going to be as accurate if you had a building corner or edge of road or something of that nature, something more permanent. So in this example, there's some buildings, there's some edge of roads, and some corner concrete shots that were taken from the original survey that can be adjusted so we can move our points to those locations. So once you determine a shot that you can match to the aerial, draw a polyline from the surveyed point. Make sure the endpoint object snap is on. This ensures that the polyline you will draw will be the same elevation as the survey point elevation to the aerial map point. Another option is to type in the command line osnapz and change it from 0 to 1. This will not allow the object to change elevation when being moved. So in prior trainings, if you had a point and you took that point, a survey point, and you move that, it would change the elevation because the osnapz is set to 0, meaning that it'll adjust it based off of that surface. If you change it to 1, it will not change that elevation of that object or that point. So that's another way of doing this. So this is the corner of the building that will be used in adjusting the original survey points to. So we know that elevation. We know that shot that we took. As you can see here, this is the building corner, and as shown in the properties, the polyline has an elevation of 353.84. Now, if you select that polyline and it has a 0 elevation, you want to make sure that you change that elevation to the correct elevation of that point. Or changing that osnapz to 1, it will allow you to move these points and not change the elevation. But if it's set to 0 and you move these points, it's going to adjust those point elevations as you move them. So probably the safest bet is to turn your osnapz to 1, and then that way you know that all those elevations are going to remain the same as you move them along that polyline. Polyline must be drawn to a location on the area map in Civil 3D, so that's where we're just talking about. We have that building corner that we shot, and then to the building corner on the aerial map. And sometimes it is a little bit hard to decipher, the map, because it's going to be so far away from where you're surveying. But just keep in mind that 5,000, 10,000 is going to be on the bottom left-hand corner of that map in our templates. So it should give you some idea of where your location is compared to where the map is at. Once you created that polyline, you can now select all your points and any line work. If you've started your drawing and you can select everything at once, most of the time this should happen as soon as you come into the office after you've done a survey and you wanted to move the points. But if you do have line work, you can most certainly make sure all that line work is on and you move all that at one time. Because if you have existing buildings and such, it might be a lot easier if you draw those existing building corners in, or concrete or edge of road, that you can actually twist all that structures to and align it a little bit better with your aerial map. Once you have that done, go ahead and type in the command line move, select the endpoint of the polyline, move the mouse along the entire length of the polyline until you reach the end of the polyline that is on the aerial map. Again, if you have your OSNAP set to Z, you want to make sure that you move along that entire polyline the entire time as you move those points. If you have it set to 1, it doesn't matter if you move along that polyline. And technically speaking, you don't even have to draw a polyline. The reason being, drawing that polyline is the one to help you follow that elevation going up to that location on the map instead of just trying to zoom in and out. And the other reason is to keep the elevation correct. So here's the survey data point. This is the end point. And we selected everything here as far as your points are concerned and all your line work that was drawn. And then now we're just sliding all those points up to the end of that polyline. And then left clicking to complete the command for the move. Verify that the point elevation remained the same as the original point elevation. In this example, 353.84 was the original elevation. So we're just verifying that it was 353.84 here. Now that the points have been adjusted to the aerial map, if the original survey was not completed with north facing up, you'll need to rotate the points to align with north. In this example, the building was used to rotate the points. Please keep in mind that this method is only used to assist you in having the aerial map in the background. So there's many ways of rotating your points. You can type in rotate to rotate them. You can do angles and things like that. But just make sure that this is a method just to keep that aerial map in the background with Civil 3D. The other thing is, once you do move those points, currently, that's why we name the original points as original. Now that you've moved them, you almost always have to export those points to a new file if you were to upload them into a data collector to do a stakeout or things like that. So it's all relative to that location. Even though when you originally surveyed it, it was at 5,000, 10,000, and you moved them to an actual geospatially correct location, and you go to upload those, so you're going to export these points, and then you're going to upload them into your data collector, it's going to be the same location because it's relative to what that survey has been done in. It's not meaning that, when you do that survey now, that it, when you do stakeouts or anything like that, it's going to be way off. It's relative because you've taken those points, you've exported them out, and then you're going to import them back into the data collector. It's just going to have everything shown correctly on the screen geospatially. So you have to go in there under your points, hit the export, select the name that you want to name that new text file. So if you want to call it points moved or whatever you want to do, just make sure that it's something that you're familiar with. Make sure that the format is correct. So if you surveyed in PNEZD, that's the way it should be moved, exported back. If you brought them in differently, you got to make sure that you export them the same way that you imported them. And then go ahead and click OK. Here's the original point file to the left, 5,000, 10,000, and here's the new point, northern easting, and it's adjusted that. So I recommend making a new drawing and importing those points into that drawing this way, making sure that they line up correctly based off of when you exported them. And just make sure that you note on the drawing that the points were surveyed locally and adjusted to the datum used, and in this example it would be NAD 83. So here's an example of our localized drawing. So if you were to go into your points, you can select any one of these points, for example. You go to your properties, and you can see the northern easting has been set. So in this case, we took shots of buildings, edge of roads, and we're going to be moving those points based off of a building corner and moving it to the map. So I'm in an actual template. So if I zoom out, you'll notice it's on the bottom left hand corner here. And then that's where you have to figure out, okay, where did I actually survey on a map? And that's where you have to draw your polyline in. And sometimes you can draw the map hybrid if you're not familiar with the area. And that'll give you road names and things. That way it'll get you a little bit closer to where you're at. So in this case, for this specific drawing, so this is the area where I surveyed, and this is the area I need to move my points to. So I have, building corners, I have edges of road. There's a concrete tank here that I, shot some corners on. So the first step is that I need to draw that polyline. So, and that can be on any layer. And then all we're doing is just, zooming out and drawing this polyline, right now. So right now, you'll notice that it has a 0 elevation. And you have to figure out, okay, well, where is that building corner? So I know that was the top right of that building corner. So I knew I need to move that to that location. So if I turn my O-snap on, I can move that. And again, as I zoom in, again, it comes with, how is that photo look? You can see some, shadowing and things like that, it's going to be fairly close, but it's not going to be perfect. So that's where it comes into play that, you don't want to use this for, line of sight, stakeout, things like that. This is just for using the photo in the background. Again, right now, you have that polyline set as a 0 elevation. So in this example, we want to change that to 353.84. So long as you have that selected, you can change it to 353.84. And just make sure that you don't select your polyline, but you're selecting everything. And then you're just going to type in MOVE for move. You're going to select this specific building corner point. And again, just, you kind of zoom out and just kind of follow along this polyline. And sometimes you might have to do it multiple times just because it doesn't zoom out all the way. And you have to think too, the larger this survey is, the slower it's going to be because you are moving all this data at one time. And I'd recommend that, if when you go to move this data, that you want to make sure that you set your surface, existing, ground, rebuild automatically. Just uncheck that, and that way it's not rebuilding as you go. So again, move, select that point, and zoom out. And then go to that corner of the building, go to endpoint, and just verify that that point elevation is correct. So now you've moved all your points accordingly, to that location. Now you have to rotate your points, to line up. But I'm going to show you right now doing it with the O-snap Z to 1. So I'll go ahead and undo this real quick. So now if we set this O-snap Z to 1, We can select all our points and we select move. I don't have to go along any, I can move them wherever I want. So just say I wanted to move them here. You'll notice that it doesn't change the elevation. So if I were to keep that O-snap Z to 0 and move those same points and not move them along that polyline like we did earlier, and we'll just move them a little bit, and you'll see that the elevation will change. So we'll undo that, turning that O-snap Z to 1, move again, just select that corner of the building, we can zoom out, don't have to go along that specific polyline. It's just nice to draw that polyline in regardless, just so you know where you're going, and then you can snap to it. And then 350, 384, it stayed the same elevation as it was originally. We want to just select, everything, all our points. We want to select it. There's many ways of doing this, but the easiest way that I do is you can do rotate and then just select that base point, and you can select, 90 degrees, however you want to do it. But if you have, lines drawn in there, you can see as I'm drawing or as it's rotating, you can see the building, moving, and you can kind of see if you zoom out where the actual other buildings are and the tank and things like that, I can get it lined up fairly close, just by rotating everything, based off of the buildings, the edge of road, and get it fairly close to what I actually surveyed. And again, it all comes down to, it's not going to be perfect. For example, this was surveyed as, a utility propane tank. That's all based off the photo. I mean, this could be true where it's at, or, this entire points need to be moved over because of the actual photo itself. I mean, yeah, the buildings might line up, fairly close. Maybe they need to be moved up and to the left. To my point, I wouldn't use this, as a die-hard way of, having points there that you're going to use for stakeout or anything like that. It's just used to, have that photo in the background if you need to, see where your points are located and kind of get an idea of what's, around the area based off of that, aerial photograph that's in Civil 3D. And then make sure you just turn your surface back on and then rebuild automatically, and then it shows up correctly. If you don't see your surface that's sitting here when you have this built, take a look around in the drawing itself, and it might be somewhere else, and you have to update the points from drawing in order to create that surface correctly. So just verify that your points are there again, and then, like I said, you make sure you have to go in here and export these points. Label it whatever you want. So I'd recommend going ahead and open up a new drawing. and importing those points just to verify that those points are coming in correctly, or you export them correctly. Again, it's the same process. Update your points. Then you can zoom to so now you'll notice my points have been updated, from what I've done before, based off of what I moved. So if you needed to move all your line work and things like that, you can select all that. Um, and then once you have all that selected, you can just hit clipboard copy, go on your new drawing, clipboard, paste to original coordinates, and then all that line work is pasted in correctly. So just make sure when you have completed the drawing and you move those points, make sure that you note on the drawing that the points were surveyed locally and adjusted to the datum used, and in this example would be NAT 83. This concludes the training on moving surveyed data points to a geospatially referenced location.